Hello, grade 12s. Today I want us to look at physical sciences, grade 12, in the side of physics, momentum, which is change in momentum, okay? Yes, so let's look at change in momentum. Um, grade 12s, remember that a momentum can change. So, of an object, of a specific object, okay? Yes, for example, if I take this pen flex, and I throw it towards the wall, the moment it leaves my hand, it's going to acquire a certain amount of momentum because it has a mass and a velocity, okay? Even if the time it reaches the wall, that was momentum before the initial momentum. Then after hitting the wall, coming back, okay? Yes. After hitting the wall, coming back means that it's going to change the direction. And it's going to also require a certain amount of the mass, which is consistent, as well as the velocity. But there will be a change in velocity right now, right? Which is going to influence a change in momentum, okay? In the opposite direction now. So let's regard opposite direction as a negative. You know that. All right. Look now. Our change in momentum is equal to momentum after minus momentum initial or momentum before, as I told you. Something that you have to, in order for us to calculate the change in momentum, we have to take the momentum after the pen bounces off from the wall, okay? Coming back, changing the direction. And you know that direction is negative, right? Because it's opposing the original motion or the first motion. Minus initially when I was throwing the pen towards the wall, okay? Now, you know that our change in momentum would be equal to, you know, that PF, which is the final momentum, PF final momentum is equal to MVF, the mass of the pen multiplied by its final velocity. And also PI, which is the initial momentum, is equal to MVI, mass of the pen multiplied by the initial velocity. And mind you that the mass is constant, right? Yeah. So we have MVF minus MVI, okay? Yes, which is going to be equal to, you can clearly see that the mass is the same, right? Yes, the mass doesn't change, the mass of the object doesn't change, okay? It stays constant, but only these two changes. So mean that in this particular case, we have to factorize that M, okay? Yes, M VF minus VI. That's it. Okay? That's it. So by the way, this is the very same thing as this and this and this. So let's climb to our example up there. So it says a tennis player serves a tennis ball with a mass of 100 grams towards his opponent with a velocity of 220 kilometers per hour east. The serve is returned by the opponent at 154.8 kilometers per hour in the opposite direction. So we have to calculate the change in momentum of the ball. Look now, great toss. In this particular case, let's just underline this. This, because we have to change it, okay? It's in grams, we have to change it into kilograms, so that we can substitute it, okay? Yes. So also this, we have to change it because it's in kilometers per hour, we have to change it to velocity, also as well as that one. So look, so you know that 100 grams divided by 1,000, that's going to lead us to kilograms. How many kilograms? 0.1 kilograms. Simple and straightforward. 220 kilometers per hour divided by 3.6 is going to land at, it's going to land us in meters per second, right? 220 divided by 3.6, take it. Okay, and that is 61.11, right? So now, let's take 154, 8 divided by 3.6, change it to meters per second. So 154.8 divided by 3.6 is equal to 43, straightforward. 43. All right, now, everything seems like have been resolved in terms of the statement, okay? So our change in momentum will be equal to, okay, let me just, okay, will be equal to VF minus initial velocity, okay? Yes, so this is going to be equal to 0.1. Final velocity is Mind you that final velocity is the one when the ball was returned from the opponent. Okay? Yes, was returned back. So this is that, which is equal to 43. And mind you, it's going to be negative because it changed the direction. Mind you that the momentum and the velocity are vector quantities, okay? Yes, or vectors, because they have magnitude as well as the direction. Okay? Yes. So the final velocity will be negative 43, yes, minus the initial velocity, which is 61,11, 61,11. So this will be equal to 0,1. So let's just punch that into our calculator. So negative 43 minus 61,11, that's going to be equal to, and let's multiply this by 0,1. So negative 0, okay, so 0,1 multiplied by negative 104,11. So the answer here is negative 10,411. So kgs, meters per second. Mind you guys, we can't leave the answer in that negative form. We can't leave it in that form. So mean that we have to just say that, yes, for the fact that it's negative, mean that it's coming from the opposite direction, right? Yes. So mean that there was a change in momentum there. So as you can see there, the first server sends the ball eastwards and the ball was returned west. So mean that this opposite direction is west. Okay? Yes, so 10,441. So sorry, I said 411, 41, okay? Yes. So 41 kgs meters per second. That's how it goes. And that's west, okay? Yes, don't forget west. This is the end of our lesson video. For more lesson connects, subscribe and the video. Cheers.